Welcome to The Explainer. Today, we are diving deep into a tool that's, well, it's pretty much everywhere in modern software, but it can also be kind of confusing. We're talking about Kubernetes.
All right, so let's set the scene. You've done the smart thing. You've containerized your application. You're feeling good. You've got, say, 100 containers running, and then it hits you. Now what? Because, let's be real, managing a few containers is one thing, but hundreds, that's not just a challenge. It's straight up chaos.
And this is what we call the container chaos problem. Because really, at that scale, you stop managing an application and you start managing, well, just pure chaos. Let's break down what that chaos actually looks like in the real world.
Okay, picture this. It's 3 in the morning. Your pager goes off. A container crashed. But which one? And on which server? Did it even try to restart itself? How do you even know it went down in the first place? Suddenly you're scrambling, trying to manually hunt down the problem. It's stressful, it's slow, and you're just reacting to disasters.
Or how about this? It's Black Friday. Traffic is going through the roof. You know you need to spin up, say, 50 more containers, and you need them right now. But doing it manually, that's going to take you, 30 minutes? By then, the spike is over, and you've lost all those sales. The opportunity is just gone.
And then there's the thing that gives every engineer anxiety: deploying a new version. The old way meant stopping all your containers, starting up the new ones, and just hoping for the best. And what does that mean? It means you have to accept like 5 minutes of total downtime. In today's world, that's an absolute eternity for your users.
So you've got these late-night failures, this painful manual scaling, and these super risky deployments. This whole mess, this chaos, is exactly why something called container orchestration was created. It's a fancy term, but at its heart, it's all about one thing: automation.
Okay, so how do we fix this chaos? To really get what Kubernetes does, let's use an analogy. It's a great one, I promise. Think of all your servers and all your containers like a gigantic, bustling shipping port.
So on one hand, you have the manual port. It's just chaos, right? You got workers running around, trying to find empty space, moving these heavy containers by hand, and just praying nothing falls over. On the other hand, you have the automated port. This is Kubernetes. There's a central control center that automatically finds the best server for a container, instantly notices if one crashes and replaces it, and even adds more containers when traffic gets heavy. It's the difference between pure mayhem and a beautifully orchestrated system. So let's just lay it all out. Manually, when something breaks, you're waking up at 3 a.m. to go fix it. With Kubernetes, it's self-healing. It restarts automatically. Manually, you're scrambling to start and stop containers to handle traffic. With Kubernetes, it auto-scales based on what's actually happening. And those terrifying updates where you have to take everything down? Nope. Kubernetes gives you rolling updates with zero downtime. It basically takes all the most painful parts of the job and just handles them.
Okay, let's zoom in on one of the most incredible features of Kubernetes. It's called self-healing, and honestly, it's kinda magic. This is the feature that lets you actually sleep through the night.
So here's how that magic trick works. Let's say one of your containers, or as Kubernetes calls them, a pod, just fails. It crashes. The control plane, that's our control tower, sees it happen instantly. It doesn't even pause. It just says, okay, that one's gone, finds another server with room, and spins up a brand new healthy replacement. The whole service is restored, automatically, usually before a single user even notices anything was wrong. No human has to do a thing.
But it's not just about fixing things when they break. Kubernetes also completely transforms how you do updates. It takes that super stressful, high-risk event and turns it into a totally routine, safe, and frankly, boring operation, which is exactly what you want. So this is the old, painful way. It's called the recreate strategy. Step 1, stop all the old containers. Step 2, start all the new ones. The result? Guaranteed downtime. Your users are absolutely going to see an error page. There's no way around it.
Now here's the Kubernetes way, the rolling update. This is so much smarter. It brings up one new container, and then it waits. It checks to make sure the new one is perfectly healthy and ready to go. And only then does it take one of the old ones offline. It just repeats this process, one by one, nice and graceful, until the entire update is done. And the result? Zero downtime. It's seamless.
Okay, but that phrase I just used, know if a container is healthy,
That brings us to a super important point, and actually a really common mistake people make. It really shows you how sophisticated Kubernetes is, because it's not just asking a simple question like, hey, is your app running? It's asking much, much smarter questions.
Think about it. A container's main process could be running just fine, but the application inside it? It could be totally broken. Maybe it's stuck in an infinite loop, maybe it can't connect to the database. It's like a person who is breathing, but they're in a coma. They're technically alive, but they can't do any work. Kubernetes needs to know the difference.
And the way it figures this out is brilliant. It uses two different kinds of health checks, which are called probes. First, there's the liveness probe. This one asks a very simple, very brutal question. Are you alive or do you need to be put out of your misery? If this probe fails, Kubernetes just restarts the container. It's a goner. Then there's the readiness probe. This one asks a more subtle question. Are you ready to take on work right now? If this one fails, Kubernetes doesn't kill the container. It just says, okay, you're not ready yet. I'll stop sending traffic your way for a bit and check back later.
And here's a real-world example of why that difference is an absolute game changer. Imagine your app starts up. It might need, 30 seconds to load all its data from the database. During that startup time, the liveness probe passes. The app is running. But the readiness probe is failing because it's not ready for traffic yet. So what does Kubernetes do? It keeps the pod alive, but it doesn't send a single user to it. Once the data is loaded and the readiness probe passes, then it opens the floodgates. This completely prevents a storm of errors every time you restart your app.
And that really brings us to the core idea here. Kubernetes forces you to ask a better question. You stop asking, is my app running? And you start asking, is my app resilient? It's a fundamental shift in mindset. It's about building systems that expect failure, that know how to recover, and that can handle the absolute chaos of the real world, all on their own.